Good day, everyone. Today, our topic is about exception handling. So this is part of the final term. So in this presentation, we will be covering the following topics. First, we have introduction. Under the introduction, we're going to introduce the topic of exception handling in Java and explain its importance in creating robust and reliable software. The second topic is we're going to define what is exception. Okay, so in this topic, we're going to provide examples of situation that can cause exception in our programs. The third topic is about the types of exceptions in Java. So there are basically two. There are two types of exceptions. So these are checked and unchecked exceptions. So we're going to provide examples for each, and we're going to compare and contrast these two exceptions. Topic four is about the try and catch block. So we're going to introduce how to use the try and catch block and explain how it is used to handle exception in our program. The fifth topic is the syntax in handling exception. Then we have using multiple blocks or using multiple catch blocks. Okay, so this can be used to handle different exceptions. Then we're going to use the finally blocks. So in this topic, we're going to explain how it is used to ensure a certain code is always, uh, this is a code that is always executed regardless of whether an exception occurs or not. And then the last topic is throwing exception. So we're going to explain how to throw exception in Java using the keyword throw or throws. Okay, so let's start. Let's begin with the introduction. So in this presentation, we will be discussing uh, what exceptions are and why they are important and how they are how to handle them in our programs. So, as you may know, an exception is an event that occurs during the program execution that disrupts the normal flow of the program. So, this can happen due to variety of reasons, such as incorrect user input, fault code, or problems within the system. So, if these exceptions are left unhandled, so exception can cause program to crash or behave in unpredictable way. So that's why it is important to understand how to properly handle the exception in our programs. So by using exception handling techniques, the developers, can anticipate the possible errors and can take appropriate action to prevent the program failure. So in Java, exceptions are handled using the try and catch blocks, where the code may throw an exception and is enclosed in a try block. Then the corresponding error handling code is placed within the catch block. So we have the try and then the catch block. If there's an error occur in the try block, so we will handle it using the catch block. So in this way, we can create a robust and reliable program that can handle errors and continue to operate normally, even when unexpected error or unexpected event occurs. So let's learn more about this exception handling. So let's define what is exception handling. And let's get the next slide. Okay. So we can define exception as unexpected error or it is unexpected condition the the program you write can generate many types of potential um, exception. So a program might issue a command to read file from disk. So, but the file does not exist there, or a program might attempt to write data to a particular disk, but the disk is already full, or the disk is unformatted. So in that case, we cannot store um, additional file to the disk. So a program might ask uh, user to input, but the user enters an invalid data type. For example, the user the text field accepts only numerical types, or the text field accepts string data, but the user enters numerical data. So there would be invalid data type, or invalid or data type mismatch. So a program might attempt to um, another example, a program might attempt to access an array with a subscript that is too large or too small. So we can also encounter another exceptions. Okay. So these errors are called exceptions because presumably they are not usual occurrence. So they are exceptional. Exception handling is the name for the object-oriented techniques that manage or resolve such errors. Okay. So let's move. So there are two types, like what I mentioned, there are two types of exception. There are check exceptions and unchecked exception. So the check exceptions are those that the compiler requires the programmer to handle explicitly, either by catching the exception or by declaring that the method throws an exception. On the other hand, unchecked exceptions are those that are not required to be handled explicitly by the programmer. They can be thrown by the program at any time and are usually a result of the programming errors, such as null pointer reference, or array index out of bounds. Okay, so let's go deep with these two types of exception. So let's learn about the check exception. So we mentioned that check exceptions are uh, we can we can encounter this exception uh, using the compiler or during the compile time. So the check exceptions are checked by the compiler. So this exception must be declared in the method signature with the keyword throws, or handled using a try and catch block. So we can use the keyword throws, or we can use the try catch block. Uh, and then check exceptions are generally used to handle exceptional condition that are outside the control of the program, such as the file input output errors or network connection failures. So these are examples of check exception. So this includes the input output exception, the SQL exception, and the class not found exception. Okay. So to further explain, check exception is an exception that must be either caught or detected in the method signature using the keyword throws. So the check exception are checked by the compiler at the compile time to ensure that they are properly handled by the program. So when the method throws a check exception, the caller of the method must either catch the exception or declare that it may be thrown the exception. So if the exception is not caught or declared at the compilation, so the compilation error will occur. So check exceptions are generally used to handle exceptional conditions that are outside the control of the program. Like what we have mentioned, we have the IO, We have the network, we have the SQL exception, and many more. So so this is the example of you know, so this is an example of a check exception. So we have imported the java.io. So this is the package for input output. As you can see, so the main method, under the main method, so we included the keyword cross IO exception. So in this um, set of code, so we are expecting so in this example, the main method, so that reads input from the user using the buffer reader. So we have used buffer reader under the java.io package. So in case that an error occurs, using this code sequence, so we can the method can throw the IO exception. So it must either be caught or declared in the method signature. Yeah. So in this example, so we included throws IO. So in this case, we have chosen to declare the IO in the main method signature using the throws keyword. So by declaring the check exception in the method signature, we are indicating that the caller of the method must either catch the exception or declare it that it may throw the exception. So this ensures that any unexpected errors that occurs during the execution of the program are handled and is robust and in a reliable way. So okay. So next would be the unchecked exception. So the unchecked exception are not checked by the compiler at the compile time. So these exceptions do not need to be declared in the method signature or handled using a try catch block. So unchecked exceptions are generally used to handle programming errors such as null pointer exceptions, array index out of bounds errors. So examples of unchecked exceptions include null pointer. So we have array index out of bounds. We have illegal argument exception and many more. So so like what you have mentioned, an unchecked exception is an exception that is not required to be caught or declared in the method signature. The unchecked exception are not checked by the compiler the compile time, which means that the programmer does not have to handle them explicitly. So it means that we do not need to explicitly do handle these exceptions. So these exception typically caused by programming errors, and nabanggit na natin to kanina, null pointer exception, array index out of bounds, or illegal argument expectation. So these types of exception generally indicates a bug in the program rather than an external condition that is beyond the program's control. So let's check the example. So this is example of unchecked exception. So in this example, so we declare uh, an an array of integers with the following values 1, 2, and 3. And then we want to retrieve the array with the index 3. So in this example, so this code will have an error. So the main method, so in this example, the main method try to access the fourth element. So of an array that contains only three elements. So our array in this example contains only three elements, 1, 2, and 3. But But under the second statement, system that out, that means we are trying to display the value of array index number 3. So in this code, so this will cause an array index out of bound exception. So we need to be thrown at runtime, which is an example of unchecked exception. Since unchecked exception do not need to be caught or declared, they can make programs more concise and easier to read. So however, so they can also make a program less robust since unexpected error may cause the program to crash or behave unexpected ways. So it is generally a good practice to handle exception explicitly whenever possible. So even if they are unchecked, so in order to ensure that the program behaves predictably and robustly. So let's proceed to the next topic. So we can handle error using this try and catch. So the try and catch block is used to handle exception that may occur during the execution of the program. The try block contains the code that may throw the exception, while the catch block contains the code that handles exception if it occurs. And so this is the syntax of the try and uh, catch block. So we have this keyword and then pair of open and close curly brace. We place inside this curly brace the code that may be thrown, that may throw an exception. So if this line of code produces an error or an exception, the catch block will uh, that this catch block with the corresponding exception type will handle the exception generated or found in the try block. So let's see this example. So the try and catch block example. So in this example, so we created. So in this example, so the main method it reads input. So using buffer reader uh, and attempts to parse it as an integer. So we want they try to convert the value into an integer. So if an input output exception or the number format exception occurs during the execution of the try block, so this is the try block, and then we prepared two catch blocks. So in this example, so we have multiple catch blocks. So we are trying this code that this code might uh, produce two exceptions. The first exception is the input output exception, and then the second is number format exception. So we created the two catch blocks, and inside the catch block, we display an error message. So this message error reading input, and we display the corresponding message using that function get message. On the same way, so we have number format exception. So we are trying to display that the user enters invalid input. Okay. So it is generally good practice. So this is an example of using catch blocks, try and catch block. So using multiple catch blocks. So it is generally good practice to handle exception explicitly whenever possible. So even if they are unchecked, so in order to ensure that the program behaves predictably. Okay. So how about the multiple catch blocks? So in our previous examples, in our previous example, we use the IO exception and the number format exception to catch or to perform whenever an error occur within this code within the try block. So we have two catch blocks. So this is the syntax. The following would be the syntax of the multiple catch blocks. So it is possible to have multiple catch blocks, similar to our previous example. Okay, so these catch blocks can handle different types of exceptions, so which may occur during the program execution. So the catch blocks are executed in order from top to bottom until the exception is caught and handled. So each catch block can handle specific type of exception or superclass of that exception. So in this example, so let's check this example. So in this example, so we have exception type 1, exception type 2, and exception type n. So these exceptions are different types of exception that may occur during the execution of the try block. So if an exception type, so for example, exception type 1 is thrown, so the first catch block is executed to handle it. So if an exception type 2 is thrown, the second catch block is executed to handle it, and so on. So each catch block can handle exception in its own way. So such as flagging the error, displaying error message to the user, or taking another appropriate action to recover from an error, or to catch a block that can also rethrow the exception or throw a new exception if necessary. So let's have the actual example of having a multiple catch block. So in this example, we can see that we have the the array. So in this example, the main method tries to access the fourth element. So the fourth element here, there's no fourth element. So this is the first element, index 0, index 1. Index 1 is number 2, and then the element of the tree is under index number 2. So there is no array index 3. So in this case, so it will cause an error. So we have three we have three catch blocks. The first catch block is array index out of bounds exception. So we want to issue an error that the the array index is out of bounds when the this try block encounters exception in arithmetic. So if it catches arithmetic exception, so it will display arithmetic error or exception, simply exception. So this is a known error. So we have three different catch blocks. So these three different catch blocks corresponds to different exceptions. So by using multiple catch blocks, the programmer or we can handle different types of exception or the condition in a structured and reliable way, thus ensuring that the program behave predictably and robustly in case that an error or an unexpected error occurs. So again, so this is generally a good practice to handle exception explicitly whenever possible, even if they were unchecked, in order to ensure that the program behaves predictably. Okay? Then for the finally block. Okay. So how to use the finally block? So first, what is finally block? So the finally block is used to provide a piece of code that is guaranteed to be executed whenever or whether or not exception is thrown. The finally block is used to clean up resources that were acquired during the program execution, such as closing database connection or closing a file, regardless whether an exception occur or not. So the finally block, so basically, regardless if an error occurs or exception occurs or there's no exception or there's no error, so the finally block, the code that we will place inside this block will be executed. Okay, so let's see this example. So let's see this example. So this is an example of a program that uses the try, the try, the catch, and finally block. So in this example, the program tries to read the content of a file and print them to the console. So if an exception occurs while reading the file, the catch block is executed to handle the exception and display an appropriate error message, regardless of whether an exception occurred or not. So the finally block is executed to close the file and release any resources associated with it. So if an error occurs, so while closing the file, so as you can see here, so there's another set of try and catch. So while we close the file, so we have another set of try and catch block. So this catch and block within the finally block is executed to handle specific error. Next, so how can we throw exception? So throwing exception in Java allows us to create and throw exception based on specific condition or errors that occur during the execution of the program. So you can use the throw statement to manually throw uh, exception. And you should only throw exception in exceptional circumstances. When throwing exception, be sure to provide a clear error message to help diagnose and resolve the issue. So let's check this example. So how can we throw an exception? So in this example, if the input value is negative, so an instance of illegal argument exception class is created using the constructor that takes a string parameter. So this is the illegal argument exception, and then this is our message. Now, so the error message is passed as the string parameter, which will be displayed when the exception is caught and handled. Okay. So we have this keyword throw, and then we created a new exception, new instance of a illegal argument exception, and then this is the string value or the message. So it is important to note that you should only throw exception in an exceptional circumstances, such as when an error or unexpected condition occurs, which will prevent your code from functioning properly. So throwing exception for routine or expected condition can cause unnecessary overhead, rather. So unnecessary overhead and negative impact to the performance of your program. Okay, so let's check this example. No? So in this example, so the divide method is defined to take two integer parameters and return their division. So and return their division. So if the second parameter b is 0, the method throws an arithmetic exception with the message cannot divide by 0. So in the main method, we call the divide method with 10 and 0. So here's the function called divide, 10 and 0. So since 0 is not a valid divisor, the divide method throws an arithmetic exception, which is caught by the catch block. The catch block prints the error message to the console. So when throwing an exception, it is important to declare an exception in the method signature using the keyword throws. So this informs the caller that the method may throw exception and allows the caller to handle exception to pass it up the call stop. So in this example, so we have here uh, the divide function. So we use the keyword throws, and then we have the arithmetic exception. So this is the name of the exception that we want to handle, and we want to throw the arithmetic exception. So using this uh, class or the arithmetic exception. So we will display message that uh, we cannot divide number by 0. Okay, so in this example, we divided, yan. So we divided, uh, so in this example, the divide method declares that it may throw arithmetic expression using the throw keyword. Okay, and this allows the main method to catch exception and handle it appropriately. So for the last stop or for the last slide, so the exception classes. So these are some of the commonly used or examples of exception classes in Java. So we all know that Java has already created the pre-made classes, or it provides wide range of exception classes that we can use to handle different types of exception or different types of situation or condition. So this condition occurs during the program execution. So these are some of the most commonly used. First is arithmetic exception. So the arithmetic exception is thrown when there's arithmetic operation result in an error such as division by 0. Second is null pointer exception. So this exception can occur or can be thrown when a null reference is used in a way that requires a non-null reference. So if we put a null instead of inserting a null reference, and it requires a non-null reference, so it will issue a null pointer exception. So it means that we need to have a reference, and it should have a value. We should have a value for our reference. It should not be null. So that's in that case. So we can capture this exception or situation. Third is array index out of bound exception. So this exception, if we want to access an index which is out of range. So for example, we declare 5 elements. So the index of these 5 elements begin with 0. So the elements, if we have 5 elements, if we have array with 5 elements, the index are 0, 1, 2, 3, and 4. And when we try to access the fifth element, so it should be 4. The index should be 4, not 5. And if we put number 5, So an index out of bounds exception would be used to capture this uh, exception. And aside from illegal arguments, array index out of bounds, so we have illegal argument exception. So this is thrown when an illegal argument is passed to a method. Example of this illegal argument when we have two integers as the argument or parameter of a particular method, and we try to put strings as parameter or argument. So this will issue an illegal argument exception. So then we also have the class cast exception. So this exception is thrown when an attempt is made to cast an object to a type that it is not compatible with. So, okay, so I know you are all familiar with the type casting. So this is somewhat related to that, class cast exception. So if there are two two objects, or if there are objects that we want to create, so these objects uh, should be compatible uh, with it should have the same ancestor, or it should have within the hierarchy, or within the class hierarchy of a particular class. Then we have the IO exception. So IO exception is thrown when IO operation fail, such as when reading or writing a file. Then we have the SQL exception. So this is thrown when error occurs while accessing a database. So when we can use SQL exception when accessing our database. Then file not found exception. So this exception is thrown when file cannot be found within the drive or within a particular URL. Then we have interrupted execution exception. Okay, interrupted exception. So this exception is thrown when a thread is interrupted while it is sleeping or waiting. And then we have the runtime exception. So this is the superclass of all unchecked exception in Java. So these are examples of exception classes uh, that can be used. Okay, so these are just few examples of the many exception classes available in Java. So by using these classes or we can also create our custom exception classes. So the programmer can handle different types of exceptional conditions in a structured and reliable way. Thus, so our program will behave predictably, and it is robust in the face of unexpected errors. Okay. So I think that ends our lecture. So thank you for listening, and okay, so thank you and God bless. See you next meeting. Bye.